Alright, so here we have an example, and we're given that Q is the midpoint of PR, line segment PR, right here. Q is the midpoint of PR, and R is the midpoint of QS. Okay, and we're trying to prove that PR is equal to the measure of QS. Okay, so our first statement is always going to be our given, right? So I'm going to say Q is midpoint of line segment measure of line segment PR, right? And then also I'm going to say R is midpoint of line segment, measure of line segment QS. And the reason for that would be given. Alright, so now this is going to be another new statement and reason, right, in our proofs. It's the definition of midpoint. And what is the definition of midpoint let us say? Well, the definition of midpoint lets us say that since Q is the midpoint of PR, right, then we could say that the first half, PQ, is equal to the measure of the second half, QR. And so that's what I'm going to say here. I'm going to say, I'm going to say the measure of PQ, without that line on top, is equal to the measure of QR. And I'm also going to do the same thing over here, right? Because we also are given that R is the midpoint of QS, that segment there. R is the midpoint of QS. So that means this first side is equal to that second side. So I'm also going to say measure of QR is equal to the measure of RS. So number 2. And that is going to be the definition of the midpoint. The definition of midpoint lets us say that. Okay, so this is a new statement and reason. We haven't seen this before. Okay, and so from here we're trying to say PR is equal to QS, and so we also want to say that we could say that PQ, this segment here, is equal to RS, this statement over here. So that's going to be our third one. Measure of PQ is equal to the measure of RS. And how are we able to say that? How are we able to say that PQ is equal to RS? Well, we have here PQ is equal to QR, and QR is equal to RS, right? So we're able to say PQ is equal to RS. And so what's our reason for that one? Well, it's transitive property. Okay, so now that we're here, what we can do is take this line segment, PR, and use this segment addition postulate, the star of our show today. All right. So what are we going to say here? We're going to say the entire segment, the measure of PR, is equal to the first part plus the second part. Okay. So we're able to come up with an equation. So we could say that measure of PR, is equal to the measure of PQ plus the measure of QR. And I'm also going to do the same thing with this line segment too. I'm going to do this one, use segment addition postulate, and I'm also going to do this one there. Okay, so I'm going to say the measure of QS is equal to the measure of QR plus RS, like so. And the reason that we're able to say this is the segment addition postulate. Okay, so now we're here and we're almost done, right? We just need to do a little bit of substitution. And so my next statement, number 5, is going to say that PR is equal to RS plus QR. And how am I able to get from here, this equation, to here, right? And what did I do? I took PQ and I replaced it with RS. And how could I do that? It's because right here I have PQ is equal to RS. Right? So I can replace PQ with what it's equal to, namely RS. So the reason for this one would be substitution prop. And then lastly, we can get to our proof. Right? And how can we get to our proof? Because RS plus QR is equal to QS, right? So now instead of writing RS plus QR, we're going to write QS. So our statement 6 is going to be PR is equal to QS. And my reason for that would also be substitution property. All right, so whenever you see a figure that looks like this, like you see, we see it again, right? You want to use segment addition postulate there, and then you want to use segment addition postulate there as well to come up with two equations that you can use along with your givens and substitute in all the algebraic properties to finally get to the proof. All right? So whenever you see this kind of a figure with 4 dots on a line, 4 points on a line, segment addition postulate on the left side, segment addition postulate on the right side to come up with two equations that you can work with. Whenever you are given a figure that looks like this, 3 collinear points on a line, you want to do segment addition postulate, right? Once. So like the entire segment is equal to the first half plus the second half. Okay, so I'm going to go ahead and stop right there.